Welcome back everyone to my 4th devlog on the Necrotic Trials. Today is going to be a big day. Over the last few devlogs, we've built multiple isolated systems, such as a grid, health bars and stats, as well as ability shapes. And now is finally the time to bring them all together. In order to get abilities to function, I needed some way to create gameplay effects that represent each ability. This can include things like playing the animation, dealing damage, applying a status effect, or even shaking the screen. Following the theme of modularity, I wanted some way to add these gameplay effects to an ability without tightly coupling them. My initial approach involved the use of scriptable objects. Each effect would have its own unique object queued up in a list, set to execute synchronously in the order they were added. However, this approach had considerable drawbacks. The most glaring issue was the absence of support for asynchronous effects. For instance, if I intended to run an animation and a sound effect concurrently, I'd be stuck. Sure, I could include a switch to flip between asynchronous and synchronous, but this would still leave me in a bind if I wished to combine both or alternate between them. Furthermore, what if I wanted to add flow control? For instance, playing an effect on an animation event trigger. Or perhaps I might need to check for certain conditions, like whether or not a target is affected by a specific debuff. These are all things that would be tricky to implement using this approach. Not even mentioning the avalanche of scriptable objects would be a nightmare to manage and navigate. Even with folder segregation, the task of working with a tree file system layout would be chaotic. After spending way longer than I care to admit on brainstorming different ways to handle this, I was actually pretty close to giving up on the modular side and just hard-coding all the abilities. I mean, the outcome is the same, right? Although I really did not want to do this, so fortunately I stumbled across a free framework called BaseNode, which is an open source node editor tool for Unity. This gave me an idea. Instead of using individual scriptable objects for each effect for each ability definition would have a single scriptable object that represented the ability graph. This graph would contain all the effects as well as the flow between each effect, making it much easier to manage and change abilities. Okay, that was a pretty big info dump, so let me just dive in and hopefully it will make sense as I explain it. The core of the ability graph is the BaseNode class. This is an abstract class that represents all nodes that can be executed. Each node overrides the execute function with whatever implementation is needed, such as playing an animation or dealing damage. The protected function executeNextNode is what handles the logic of executing any nodes that are connected to the current one. If we take a look inside, we can see it's actually pretty straightforward. We first get all the connections, order them by the Y position so they execute top down, and then loop through each one and either add it to the currently executed coroutine or start a new coroutine if you want asynchronous behavior. Now let's take a look at 2 example abilities and how they work. First, the move ability, which is going to be the main way units move across the map. Here is the graph for this ability. Asynchronously, we first disable the root motion, since the movement is being controlled with code and not baked into the animation itself. Then we set the speed in the animator, which transitions the character from idle to walking. And lastly, we actually do the movement, and reset the animation back to idle once we arrive. Looking into the movement node, we can see that movement is done by first getting the tile we want to move to, then using A-star pathfinding to get a list of grid positions that represent the path, and loop through each one to move to it using vector3.moveTowards. The tricky part came with the path arrows, which took a lot of trial and error. Luckily, with the help of some gizmos, I managed to get it working. Let's say we have a path with a unit starting on tile -1, -1. We can compare the direction to the previous tile with the direction to the next tile to determine which arrow we need to place. If both directions are the same, that means we are traveling in the same direction and can place a straight line. However, if the directions differ, that means we are turning and need to add a curve. If no next direction exists, that means we have reached the end of the path and can place an arrow. Unfortunately, the code for this is quite ugly, so please forgive me, but I could not find a better way of doing this outside of just using if statements. The next ability I'll go through is a simple sword swing ability. This will most likely be the basic attack of the two-handed sword unit. As you can see with this graph, there is actually quite a bit going on. For one, I separated rotation out into its own node, unlike in movement which has it built in. The reasoning for this is in some attacks, such as area of effect skills, might now require the unit to rotate to look at its target. Another new feature that wasn't in the movement graph is the ability to play animations on both the casting and target units. In this case, when the sword swing hits its climax, the hit animation event is triggered, which then resumes the graph to play the hit animation on the target as well as deal the damage. To get the damage amount, we can use the formula node. This allows me to enter any mathematical equation with the keywords caster and target. These keywords can subsequently be linked with a stat definition scriptable object, thereby integrating their respective stat values for either the caster or the target back into the equation. In this case, this ability will deal the caster's physical damage plus 10% of the target's maximum health. This was very fun to build, and was achieved using a combination of regular expressions, dynamic creation of node ports, and the use of the C# NuGet package NCalc, which allows the calculation of mathematical equations at runtime. Whew, okay, that was a lot. Hopefully I didn't lose too many of you. There are still a ton of changes I made that I haven't covered yet, including a revamped target selection system supporting multi-unit selection, and an improved ability bar offering ability previews on hover and disabling buttons during ability casting. Sadly, if I cover every change I made, this video would be an hour long. If you are curious on how certain things worked that I didn't cover, or even more explanations on the ones that I did, post them in the Discord and I'll try my best to answer them. My goal for the next devlog is to spend some time cleaning up code, but then I actually need to start working on gameplay. Things such as summoning units, moving from room to room, and enemy AI. I can't guarantee I'll get to all of that next video, but I do think it's time to start getting the gameplay loop down. Once again, thank you all for watching. Don't forget to like and subscribe if you want to stay up to date with this project. Have a great rest of your day. See you next time.